Here's a situation dealing with electric charge and electric current. So, you're searching for a new gaming mouse. You find one on Amazon. There's specifics given there in the description. One of the specifics that is important is the amount of charge that is transferred in the chemical reaction in the batteries. And for this particular mouse, 800 milliamp hours. That is the amount of charge. Typically, we express charge in coulombs. So that means we can convert milliamp hours into coulombs, and that's what we want to do in part A. So if we want to convert, well, if we can get into amps, from milliamps to amps and hours to seconds, this would be an amp second. In an amp second, an amp is a coulomb per second, and that would be times a second, which would give us coulombs of charge. So then as we proceed with this conversion, what we need to do is go from milliamps to amps and hours to seconds. Well, milli is 1/1000th, so then 1 amp is 1,000 milliamps. Hours to seconds, an hour is 3,600 seconds long. Hours on the top, hours need to go on the bottom, so 1 hour, 3,600 seconds. That's going to give us a converted value of 2,880 coulombs. So that means in that rechargeable battery, when you start with that brand new fresh battery, until you exhaust it, you complete the chemical reaction. That chemical reaction will result in 2,880 coulombs of charge being pushed in the circuit. Part B. One user claims that the battery lasted for 3 to 4 days with plenty of usage. If we assume that it lasted for 4 days and that it was being used for 2 hours a day, let's calculate what the average current is. So then delta T, 4 days, not continuously, but for 2 hours each day. So then if we want the amount of current, current is defined as quantity of charge over time. We know what the quantity of charge is because the batteries were dead at the end of the 4 days. And so our quantity of charge pushed is 2,880 coulombs. Our time period, 4 days, 2 hours each day, that would be a total of 8 hours, but then we need that in seconds. So 8 hours times 3,600 seconds in an hour. So then if we convert, we get 0.1 amps. Part C. If a play averages 47 clicks of a mouse on the mouse each minute while playing a game, approximate the charge transferred by the chemical reaction. So then we have a couple of things here. We have 47 clicks of the mouse each minute, and we want to approximate the charge transferred in the chemical reaction. Well, we have an average current here, which tells us 0.1 amps or 0.1 coulombs each second. So then if we figure out how many coulombs in a minute, that's going to be then distributed on the 47 clicks, assuming that they're all uniform. So then I is delta Q over delta T. So then this is going to be 0.1 amps is equal to delta Q over a time period of 1 minute or 60 seconds. So that's going to give us a delta Q of 6 coulombs transferred in that 1 minute. So then in that 1 minute, 6 coulombs is divided up amidst our 47 clicks, which means for each click when we do the division, about 0.13 coulombs are utilized for each click of the mouse during the game. Ponder physics.